if you can recall, when we were doing differentiation, I said the function of differentiation, the whole point of it, is to work out the gradient and to work out the rate of change. Well, in integration, the whole point of it is to work out the area under the graph. And with that, you can, start to understand things in mechanics. So let's say the total distance traveled by a plane, for instance. If you have it mapped on a graph, you work out the area under that graph, now you've got the distance or displacement. So let's have a look at an example of where you have to work out the area under the curve using integration. So the first step in this question would be to factorize this. So you want 2 brackets. Can you try that, please? Can you try and factorize y equals 20 minus x squared? So you should have got 4 minus x and 5 plus x. Okay, so when y equals 0, x equals 4 and x equals minus 5. And when x equals 0, plug that into your original function. 20 minus 0 squared is just 20. It's a quadratic graph because it's x squared, but it's a negative, which means it makes an N shape instead of a U shape. So if I were to draw it, it's going to look something like that, where this point is minus 5, this point is 4, and this point is 20. Rough sketch. Now it says, find the area of the finite region between the curve with equation blah 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 and the x-axis. So what it's asking for is the area of this portion of our graph. What you're going to do is you're going to integrate your function. In this case, it's with respect to x. And you're going to use definite integrals. So you're going to have limits. What are the limits in this case? 4 and minus 5. Because I'm working out the area under my graph between minus 5 and 4. Everything here is less than minus 5, but it's under the x-axis. Everything here is greater than 4, but still under the x-axis. We want everything in between those two numbers. With definite integrals, the larger number always goes at the top, and the smaller number always goes at the bottom. Okay, can you try and solve that for me, please? So after integrating, should have got 20x minus x squared over 2 minus x cubed over 3. And you've got the limits 4 and minus 5. When you substitute and you do your whole simplifying, you should get 243 over 2. Okay, that's how area under the graph works. Have a look at question 5 for me, please. I want you to give that a shot. Right, first step is to draw the graph. In order to draw the graph, we need to know what points it goes through the axis. In this case, if let's say we expanded this function, we would have an x cubed term, which means we've got a cubic function. Now, when y equals 0, what does x equal? X is going to be 0 x is going to be 4 and x is going to be 4. The x equals 4 is a repeating root, right? Because I can write my function like this. So x equals 0, x equals 4, x equals 4. Which means it cuts through x equals 0 and it touches x equals 4. Okay, now let's try and draw. It's going to go through 0 and it's going to touch 4. So through 0 and touches 4, like that. It says, find the area of the finite region between the curve with equation blah 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 and the x-axis. So you're going to shade this portion. So you're trying to work out the area under the graph between 0 and 4. So you write your integral for 0, because remember, larger number always comes at the top. You write your function, and it's all with respect to dx. And now it's a matter of simplifying. So for 0, if we expand our double bracket, we get this. That should be an x. And when we expand by multiply out the x on the outside, x cubed minus 8x squared plus 16x. Okay, that is what we're going to integrate. From here, you would get x to the power 4 all over 4 minus 8 over 3x cubed plus 16x squared all over 2. And square brackets 4, 0. After substituting 4 and after substituting 0 and minusing them, you should get 64 over 3. That is your final answer. And that's how you work out the area under the curve.